In this video, we are going to talk about properties of triangles, and we're going to see and really focus on three things. We're going to focus on what similar triangles are, what does it mean to have congruent triangles, and then the Pythagorean theorem. So let's get started. And we're going to start with similar triangles. So when we talk about similar triangles, we're talking about triangles that have the same shape, but not necessarily the same size. And when you hear shape, I want you to think about same angles. So it's really similar to how balls can be different sizes. Maybe we have a tennis ball and then we have a basketball or a even a softball or some other type of ball, volleyball. They have the same shape, but they have different sizes. Triangles are going to be similar. Triangles are going to be the same way. They're going to have the same basic shape, which means that they're going to have the same angles within them, but then they're going to have different side lengths, and that allows us to measure different things, and we can use ratios to help us figure out things like word problems. So let's look at a few examples. So in this example, we have a similar triangle, or they tell us these two triangles are similar triangles, ABC. So here's ABC, and then DEF. So what that means is that angle C corresponds to angle F, so they're the same measure. A is corresponding to the same measure as D, and then B and E are going to be the same. We could use these two sides in this triangle to figure out what's missing here. So we don't know the length of FG, so we're going to call it X. So we're going to set up a ratio. So we're going to say this side is to this side as this side is to this side. So we've got a fractions equal to a fraction. So we're talking about proportions, and we can cross multiply. So we have 8 times x is 8x, and 12 times 4 is 48. And then to solve for x, we're going to divide by 8. So we're going to get x is equal to 6. So that's one example of using similar triangles. So let's do a couple more examples. So if we look at these are examples of similar triangles, and we want to figure out what this side's going to be. So we're going to set up ratios to do it, just like we did before. So we're going to say this side is to this side, so 9 is to x, as 6 is to 24. And then we're going to multiply. 6 times x is 6x, and 9 times 24 is 216. To solve, I'm going to divide by 6. So x is going to be 216 divided by 6, which is 36. So we would expect this measure to be 36. We can even use similar triangles to solve word problems. Let's look at this one. Sandy's trying to measure the height of a nearby flagpole using a mirror as shown in the diagram. The mirror is 6 meters away from the flagpole and 2 meters away from Sandy. So the mirror is right here. So the mirror is 6 meters away from the flagpole and 2 meters away from Sandy. The height to her eyes is 157 centimeters, from which she can clearly see the top of the flagpole. How many centimeters tall is the flagpole? So we're looking for this. So if I were to reflect this so we can see that similar triangle a little bit better. Here's Sandy's height, 157. And this is 2 meters. And we are looking for x. So this side is to this side, as this side is to this side. And then we're going to solve. 2 times x is 2x, and 6 times 157 is 942. And then if we divide by 2, we're going to get 471, and that height would be in centimeters. So now let's look at congruent triangles. When you hear the word congruent, I want you to think about identical, because that's what it means. These triangles are going to be identical because the angles are going to measure the same and the sides are going to measure the same. So this guy is going to look just like this guy. And there's three ways we can tell whether or not two triangles are congruent. We have three options we can look at. We can look at side, side, side. And what side, side, side means is that the three sides are all equal in measure. And that this is a good example of that. We would say these are congruent. So we would say triangle ABC is congruent to triangle DEF by side, side, side. And what side, side, side says is if the sides are all equal, so AB is equal to DE, BC is equal to EF, and AC is equal to DF, then it forces these angles to be the same, which means that they are identical triangles. Another one we could look at is side angle side. Now notice that the order is going to be important. With side angle side, we're going to have two sides that are the same, and we are looking at the angle between them. So if we have two triangles, and we would say this angle is equal to this angle, this side's equal to this side, and this side's equal to this side, and we know they're equal because this one has two tick marks just like this, then they would be equivalent by side angle side. Notice that angle is wedged between the two sides. And then congruent triangles that are another option is angle side angle, which means I have these two angles, and they may not be the same measure, so I'm going to show that they're not the same measure necessarily here, and then I'm looking at this side in between. So if I have two triangles, I'll call this one ABC and then DEF. So notice B and E are the same, A and D are the same, and then that side between those two same angles has to be the same. Then we would say they're congruent by angle side angle. So let's look at this. Let's see whether or not these two triangles are congruent. So we know angle A is equal to angle F. So I could actually take this and kind of flip it around a little bit. And sometimes it's easier to be able to compare that way. This is 55 degrees. This is 80. And then F is 45. So you can see the angles are matching up. But does that tell us anything about the side lengths? And no, it doesn't. So these are not necessarily congruent. Those side lengths could be different sizes. We could take this triangle and we could stretch it apart and keep those same angles, but the lengths may not be the same. And to be congruent, they have to be completely identical. So let's look at a few more to see if they are congruent, and if they are, then how would we know? So I've got this triangle here and this triangle here. Notice they share a side. So this triangle, this side is equal to this side's length. This side is equal to this side's length. And this one, since they share a side, then it's going to be equal with itself. So this triangle has to be congruent to this triangle by side, side, side. All of the side measurements have an equal part on each triangle. So let's look at this one. So if we were to do a little flipping, maybe we take this guy and we flip it up here. So then that triangle would look something like this. So this angle would come up here, this side would be down here, and that side would be here. And then maybe we flip it to try to make it look like that. Maybe we flip it now this way. I'm sorry about how messy these are. So now this side is now on this side. And we're asking, are these two things congruent? Well, this side matches this side, and this side matches this side, but notice the angles. My top angle here is equivalent to this angle. I don't know anything about this angle. If I knew this angle was equal to this, if I knew that, then I would have side angle side, but I do not have this that. So these are not congruent, not based on the picture that we have. Let's look at that next one. So we've got two triangles here and here. And remember, these are vertical angles, which means that this angle measurement has to be equal to this angle measurement. So if I were to think about taking this and kind of flipping it, so let me see if I could draw that out. I'm going to keep that bottom one. I just kind of mirror image. So that forces this side over here, and then that 3 side over here. Is that the same thing? And we see that that one is going to be the same thing. So these guys are congruent by side, angle, side. This side, this angle, and this side, side, angle, side, they both match up. And then let's look at this last one. So I have a 90-degree angle there, and then I have a length. And then I do know something about this angle for the triangle has to be equal to this one because they are vertical angles. So I have angle, side, angle, and then I have that same angle, that same side, and that same angle. So angle, side, angle shows congruency for that top triangle and that bottom triangle. So we would say they are congruent by angle, side, angle. Now let's talk about the Pythagorean theorem. The Pythagorean theorem is used for right triangles. And you're going to know it's a right triangle because you're going to see this little box where that right angle would be. A right angle is a 90-degree angle. Which means this side is perpendicular to this side. So the legs are going to be perpendicular to each other. The hypotenuse is always the length that is directly across from the angle. And we can relate the sides together by saying a squared plus b squared is equal to c squared, where a and b are the legs of the triangle and c is always the hypotenuse. So let's look at an example. The length of one leg of a right triangle is 8 inches. So they have the leg length here. The length of the hypotenuse is 12. We want to figure out what this guy's going to be, and we're going to round to the nearest hundredth. We don't know what this is. We're going to call it b. I know that a squared plus b squared has to equal c squared. So this is leg squared plus leg squared is equal to c squared. And we could have called this a or b. It doesn't really matter. What's important is that we notice that that's a leg and that cannot be c. C is always the hypotenuse. So we're going to have 8 squared plus b squared is equal to 12 squared. So we're going to simplify this. 64 plus b squared is equal to 144. And then we're going to subtract 64 from both sides. So 144 minus 64 is 80. And then to get b by itself, we have to take the square root. We're going to do the opposite of squaring. And then when I type square root of 80 in my calculator, I'm going to get about 8.94. And that would be in inches. So that would be the length of this side. So let's look at two word problems. What is the length of the diagonal of a 10 centimeter by 15 centimeter rectangle? So let's draw a picture of what's going on. So we have a rectangle. This is 10 centimeters by 15 centimeters. We want to know how long that diagonal is. So let's look at this length. So I know this is 15, and I know this side has to be 10 also if this side is 10. And I am looking for this. So notice that this is a right angle and my hypotenuse is directly across. So I'm going to use Pythagorean theorem. A squared plus b squared is equal to c squared. These are my legs. So this would be 15 squared plus 10 squared is equal to c squared. I'm looking for the hypotenuse. 15 squared is 225. 10 squared is 100. So this is 325 is equal to c squared. And then we're going to take the square root. So we're going to get about 18.03, and that would be in centimeters. So a little over 18 centimeters. How far from the base of a house do you need to place a 15-foot ladder so that it exactly reaches the top of a 12-foot wall? So let's draw a picture of what's going on. So this is my ladder. We know the ladder is 15 feet. So that is my hypotenuse. Here's my right angle, the wall with the ground. We're looking for how far we need to place the ladder. So what is this distance? And we want to reach the top of a 12-foot wall. Now we're looking for the leg. So we know a squared plus b squared is equal to c squared. So we don't know what the side is. Instead of x, I'm going to call it a. So I've got a squared plus 12 squared is equal to 15 squared. 12 squared is 144. 15 squared is 225. So we're going to move this over by subtracting. So 225 minus 144 is 81. And then I'm going to take the square root to get a by itself. And the square root of 81 is 9. So this distance would be 9 feet. We would place it 9 feet from the wall and we would reach that height exactly.